Hey everyone, so this is a pretty classic example of an MVT problem. So given that f of x equals x squared on the interval 1 to 3, use the MVT to find a point where the instantaneous rate of change equals the average rate of change over the interval. So first thing, we always have to check the conditions for the MVT prior to applying it. So again, we have to make sure that it's both continuous and differentiable on our interval 1 to 3, which in this case we have x squared, which is just a basic parabola that looks something like that. And so we can confirm that it is both continuous and differentiable on our interval, which means we can use the MVT. So second step is we're going to find the average rate of change. This is basically just, again, our Algebra 1 slope formula. So we're going to take our farther in point, which is 3. We're going to plug it into our function. So 3 squared is just 9. Then we're going to plug in 1. 1 squared is just 1, and then we're just going to subtract our x values here over 3 minus 1, so that gives me 8 over 2, which is just equal to 4. So that tells me that for my graph, my average rate of change between 1 and 3 is equal to 4. And I'm going to try to draw this on here, and it's probably going to be much too small for you to see. But basically imagine that that is a slope of 4. So now we're going to find the instantaneous rate of change by using the derivative. So taking the derivative of x squared using the power rule, we get f prime of x equals 2x. And now we're going to set this equal to the average rate of change. So we're going to do 2x is equal to 4. Then we're going to solve this for x, right? So then we get x equals 2. So this is going to be our c value. And this is basically where our average rate of change is equal to our instantaneous rate of change. So right at x equals 2, I apologize, this graph is so small, my instantaneous rate of change there would also be 4. All right, thanks so much for watching, and I'll see you in the next one.